Imagine a future where computers don't just compute with electrons, but with the very essence of light. In today's technological landscape, data centers and AI accelerators face a formidable challenge: the limits of traditional GPU-based systems that struggle under the weight of ever-escalating computational demands. Now picture a revolutionary breakthrough, a transformation that replaces electrons with photons, using an innovative optical quantum chip to redefine performance. This new chapter in hardware innovation is unfolding in China, where a collaboration between CHIPX and Turing Quantum has yielded what many are calling a game-changing development in photonic quantum computing. At the heart of this breakthrough lies an optical quantum chip built on a 6-inch thin-film lithium niobate wafer embedded with over 1,000 highly integrated photonic components. Unlike conventional chips that rely on the flow of electrons, this state-of-the-art chip harnesses photons, transmitting information at the speed of light while generating far less heat and requiring minimal cooling. The implications are profound: a chip that dramatically reduces thermal constraints while enabling high-speed parallel data movement. Historically, the limitations of traditional GPUs have posed significant challenges for industries ranging from aerospace to finance. Conventional electronic circuits must contend with persistent heat buildup and heavy cooling infrastructures, obstacles that not only hinder performance, but also elevate operational costs. In stark contrast, the new optical quantum chip challenges these constraints head-on. By embracing the power of photonics, the chip promises to deliver up to 1,000 times the performance improvement on select AI workloads, including optimization, simulation, and complex mathematical operations. For many sectors, this technology may well break through the long-standing computational bottlenecks that have restricted innovation. The technical brilliance of this breakthrough lies not only in its use of photons, but also in its highly scalable design. Traditional systems can take months to build and calibrate. However, the pioneering architecture behind this chip enables complete systems to be assembled and deployed in as little as 2 weeks. Imagine data centers that once required painstaking assembly now coming online rapidly, their capacities expanding almost overnight. Furthermore, the design's scalability potential is nothing short of revolutionary, a future where these systems could theoretically boast up to 1 million qubits. Such a dramatic scaling capability promises to usher in an era of clustered hybrid quantum classical processing, where silicon-based computing and photonic acceleration work side by side to tackle the most energy-intensive tasks. Diving deeper, the foundation of this remarkable advancement is a robust and comprehensive manufacturing ecosystem. China's established production pipeline spans every facet of chip development, from design and fabrication to packaging, testing, software integration, and deployment. The pilot manufacturing line, capable of producing approximately 12,000 wafers annually with an estimated 350 chips per wafer, marks a significant leap over many Western initiatives that remain in the prototype phase. This integrated approach not only optimizes production, but also ensures a high degree of industrial readiness that has not been seen before in the realm of quantum photonics. At its core, this development is a powerful story of innovation meeting necessity. Traditional GPUs, exemplified by market leaders like Nvidia, have long powered our AI and data center infrastructures. However, as AI workloads become increasingly complex and energy demands soar, these conventional systems begin to show their limitations. The demand for faster, more efficient computation has never been greater, and the optical quantum chip presents a tangible solution to this very problem. It addresses the overheating and cooling challenges by employing a medium, light, that naturally circumvents these issues. In doing so, it offers a stark contrast to the status quo and hints at a future where photonic computing could dramatically alter the landscape of artificial intelligence. To appreciate the magnitude of this breakthrough, one must consider the technical challenges inherent in replacing electrons with photons. Light, by its very nature, travels at unparalleled speeds, and when harnessed within a quantum framework, it allows for high-speed parallel processing without the noise and signal degradation typically associated with electronic circuits. This is not merely an incremental upgrade. It is a paradigm shift in how we approach computational problems. The strength of the optical quantum chip lies in its ability to perform specialized tasks with a level of efficiency and speed that is simply unattainable using purely electronic means. Industry experts have taken note, with early reports and technical evaluations suggesting that on specific AI tasks, the chip can outperform traditional Nvidia GPUs by a factor of 1,000. Such impressive claims have sparked discussions in technical communities and among data center architects about the potential for this technology to revolutionize computing architectures. This optical quantum chip redefines what is possible by converging the advantages of quantum physics with practical, deployable technology. It's a tangible representation of the future, a future where hybrid data centers seamlessly integrate classical silicon computation with quantum photonic accelerators. The journey from concept to industrial adoption is rarely smooth, and this breakthrough was no exception. The development teams behind the chip faced numerous technical hurdles, from integrating thousands of photonic components on a single wafer to ensuring that the rapid scalability requirements did not compromise performance or reliability. Yet each challenge was met with precise engineering and innovative solutions. The result is a product that not only meets but exceeds the rigorous demands of modern AI workloads. In comparison to ongoing efforts in the West, where many projects are still confined to laboratory settings or limited-run prototypes, China's commitment to pushing the envelope in quantum photonics is clear and resolute. Throughout this narrative of innovation, there is an undercurrent of competition and transformation. For years, the global tech community has watched as traditional GPUs have maintained their dominance in powering AI. Now this emerging optical quantum chip signifies a potential turning point, a challenge to the established order. With its promise of superior efficiency, reduced thermal output, and rapid system deployment, the chip embodies the possibilities that arise when novel scientific principles are applied to large-scale computing. It is a bold step that could redefine the competitive landscape, inviting further exploration and potentially inspiring a cascade of similar innovations worldwide. One of the most compelling aspects of this technological breakthrough is its potential to reshape data centers into dynamic hybrid environments. As the chip enables a seamless blend of classical computing and quantum acceleration, we can begin to envision data centers that are no longer rigidly constructed around silicon-based paradigms. Instead, these centers could evolve into adaptive ecosystems that leverage the best of both worlds. In such environments, routine tasks might continue to run on traditional processors, while the heavy computational lifting is dynamically offloaded to quantum accelerators that work at the speed of light. The result could be a transformative leap in computational efficiency, paving the way for new applications and services that were previously unimaginable. Moreover, the implications of this breakthrough extend far beyond the realm of data centers. For industries that rely heavily on AI-powered analysis, simulation, and optimization, the optical quantum chip offers the promise of radically improved performance. Whether it's accelerating scientific research in biomedicine, optimizing complex financial models, or pushing the boundaries of aerospace design, the ability to perform calculations at unprecedented speeds could unlock opportunities for innovation across the board. The exponential improvement in performance on specialized AI tasks is not just about speed. It's about transcending the limitations that have long hindered progress in critical areas of research and development. Equally important is the ripple effect this technology could have on global competitiveness. By integrating photonic quantum computing into its technological arsenal, China is positioning itself at the forefront of a rapidly evolving field. This is not merely a single technological advance. It is a statement about industrial strategy and long-term vision. In contrast to many initiatives in the United States and Europe, which continue to operate at prototype levels, China's comprehensive approach, with its fully equipped manufacturing ecosystem and constant drive for industrial scalability, signals a decisive leap forward. This move could well deprive traditional GPU manufacturers of their long-held competitive advantage and force a realignment of priorities in the quest for superior computing technologies. Yet, as with any groundbreaking technology, questions remain. Will the optical quantum chip maintain its performance under real-world conditions? Can the rapidly scalable production process deliver consistent, reliable systems at the volumes promised? The coming months and years will be critical. Independent verification and extensive real-world testing will determine the practical impact of this innovation. While early reports are promising, the broader tech community awaits further evidence to see if this breakthrough will fully reshape the AI computing landscape. In reflecting on this journey of innovation, it is clear that the optical quantum chip is more than just a novel piece of hardware. It is a harbinger of a new era in computing. The transition from electron-based processing to light-based computation represents a profound shift in how we understand and utilize technology. As the boundaries of what is possible continue to expand, so too does our ability to tackle increasingly complex challenges across all sectors of modern industry. The breakthrough by CHIPX and Turing Quantum invites us to reimagine the future, one where computational limitations are overcome, where efficiency and speed become the norm, and where the realm of possibility is dramatically redefined. Today, we stand on the cusp of a revolution in AI and data center architecture. The optical quantum chip, with its promise of scalable performance and transformative efficiency, encapsulates the spirit of innovation and determination that drives our technological progress. It is a bold vision realized, and it challenges the models of the past while illuminating a path towards a brighter, faster, and more efficient future. As we conclude this exploration of China's groundbreaking optical quantum computing chip, it is clear that the landscape of AI acceleration and computing is rapidly evolving. The promise of harnessing the power of light to drive unprecedented performance improvements is undoubtedly exciting. With a manufacturing ecosystem geared towards rapid scalability and industrial readiness, the stage is set for extraordinary advancements in hybrid data center architectures. This breakthrough not only addresses pressing technical limitations, but also opens the door to a new era, where innovation is measured in photons, not electrons. Stay tuned for independent testing updates.